Okay, so this video is all about velocity, and velocity is the rate of change of position. So how fast you go from one position to the next. You should be able to answer these questions by the end of this video. So you should be able to know what velocity is, what the difference between speed and velocity is, how you can determine an object's velocity from a position time graph, and how you can represent motion with a bunch of different models. All right, so if we look at this graph here, we have two joggers, the red jogger and the blue jogger. And they have two different position versus time graphs. Okay, they both start at an origin. They both go for 3 seconds. However, the red jogger covers twice as much area, twice as much distance as the blue jogger. Okay, so the red jogger has a greater displacement. The red jogger is farther from their origin than the blue jogger. Okay. All right, so if each jogger traveled 100 meters, the time interval would be small for the jogger in the red. Okay, so you can kind of expand this out from 6 to 100. The red jogger would go over a shorter time than the blue jogger did. Okay, so we're looking at a position versus time graph. So these two have different rates of change of position. All right, so to find slope, you have to choose 2 points on the line. Okay, and then you subtract, so it's rise over run. Okay, so the slope of a position versus time graph is your velocity. And then you divide. Okay, so if we're looking at the slope of these two lines, we have the red the red jogger. Its rise is 6 meters. Okay. All right. And its time is 3 seconds. So 6 divided by 3 would be 2 meters per second. The blue jogger, its rise was 3 meters in 3 seconds. So its velocity is 1 meter per second. So the red jogger has greater speed, has a greater velocity. The slope of a position versus time graph is the velocity of the object. Okay. So this one they did a couple different, they picked 2 different points. When you start from the origin, you can just take the origin point. Okay. So the unit for slope is meters per second. Tells you how many meters the runner covered every second. So if you look at this graph here, rise is in meters, run is in seconds. Meters per second is your velocity. All right. So the slope, if we put it instead of just rise over run, we put it in the variables on the graphs. Final position minus initial position divided by final time minus initial time, or your change in position over change in time is your velocity, your slope. And again, when x gets larger, the slope gets larger. When t gets larger, the slope gets smaller. Okay, so if you cover more position in the same amount of time as you did before, your slope is going to get higher. All right. So the slope looks at the velocity of an object. Okay. The velocity means, so we look at our average velocity, change in position over change in time. Okay. So the symbol equals, so it's just velocity is position divided by time. Change in position over change in time. And velocity is a vector because it's going to have a magnitude and a direction. All right. So this is not accurate. It says, if you read this, the common misconception says that the slope of a position versus time graph gives the speed of the object. It doesn't. It gives you the velocity. Okay. If we look at this graph over here, okay, the slope of this graph, the slope of this object, it starts at 20. It goes to 0 in 4 seconds. So its rise is actually negative 20. Its run is 4. Negative 20 divided by 4 is negative 5 meters per second for its velocity. Okay, the speed is just a number. The speed is just 5 meters per second. The velocity has that position and or magnitude and direction. Okay. So yes, it says that the object moves in a negative direction at a rate of 5 meters per second. That's huge. The negative direction. So magnitude and direction, vector quantity. Okay. So the absolute slope is speed. Yeah, it's going 5 meters per second. But it's negative because it's coming back towards the origin. That's what makes it the negative. It's having a negative change in position. So your car has a speedometer. It's called a speedometer for a reason. It measures the speed. It doesn't measure the velocity unless there's a direction associated with it. Okay, the sign of the slope tells you which way it's going. Combination of the average speed and the direction is the average velocity. Okay, so if you have that speed and a direction, you have velocity. Again, here, look at this. If an object moves in a negative direction, then the displacement is negative. The object's velocity will always have the same sign as the displacement. So if you're going backwards, you're going to have a negative velocity. Okay, so we can get a motion diagram. Okay, at the beginning and end of a time interval. During that time, the speed of an object could have remained the same, increased, or decreased. All that can be determined by looking at the diagram and how basically how close or far apart your dots on your diagram are. Okay, if they're spreading out, if the dots are getting more spread out, you're increasing your how far you cover in a given time. That's a positive increasing velocity. If they get closer together, you're slowing down. Okay. All right. So although average velocity is in the same direction as displacement, the two quantities are not measured in the same units because displacement's units, velocity is meters per second. Okay. So you can use the motion diagram to get data, but it's not as precise, and sometimes it's not as clear as a graph. All right, so we have this graph here. So if we look here again, we can say that because this is linear, we can say that we can use a straight line equation, y equals mx plus b. You learned that in math class. Okay. So y is the quantity plotted on the vertical axis, m is the slope, and b is the y-intercept. Again, this should be a review. Okay, so if we look at this, y, the variable is x, because we're looking at position here. So y is position, m is your speed, the x in the equation is your time, b is your initial position. Okay, so y is where you start your position, m that's your rate of change, that's your slope. X is going to be how far it goes in a given time. B is your initial speed. So y equals mx plus b actually becomes x, your final position, equals speed times time plus your initial position. So it comes in like this, which is one of the more important equations that we have. If you have a constant velocity, you can use this equation based on the slope of the line to find your final position. Okay. All right, that is the end of the second video. Go back and watch it a couple different times if you need to. Make sure you read section 2.4, and we'll come ready to answer questions in class about graphing velocity. Thank you.